This is Unit 10, Lesson 2. And in this unit or lesson, we're going to be working on compositions, which is something new, and also working with operations over functions. So we're just going to start off by reviewing adding, subtracting, and multiplying our polynomials. Okay. Remember, a polynomial is just an expression with many terms. Okay. It doesn't have to be a specific number. So just review quickly, adding polynomials. Remember, we're just literally combining your like terms. That's it. You can drop the parentheses. They don't need to be in there. Left color's fun. Hold on, sorry. Okay, they don't need to be there. So here I'm just combining 4y and negative 3y. When I add those, I get positive y. Negative 7 plus 2 gives me minus 5. Okay, so just combining my like terms. Over here I have a squared plus 6a squared, which gives me 7a squared. Then I've got 2a and 10a and 5a. So when I add all of those, you get 17a. And then I just have a plus 1 all by itself. So plus 1. All right, subtracting. What you've got to be careful here first, and some of us are still making the silly mistake, you've got to distribute that negative to both. Okay, so whether you want to rewrite it with the signs changed, or if you can mentally see the distributing, that's fine, but make sure that this is a minus 9, okay? Without that, your answer will be wrong. So I'm doing 3x minus 4x, which is a negative x. And I've got negative 2 minus 9, which is negative 11. Please be careful, because some of us are still not distributing that negative. Over here, same thing, I distribute it, and I get plus 4z and plus 8. So I have 5z squared, so nothing to combine it with. Negative 12z plus 4 is negative 8. And then just a positive 8 because I changed its sign. All right, what we're going to be getting in today is taking a look at adding and subtracting and multiplying functions when I tell you something like this. So it's doing the same thing. However, it's writing in function notation. So all this is saying to you is add the two functions, and then I will tell you what those two functions are, and we'll see an example on the back. But that's where we're going with this. This is saying just add your f of x and your g of x. All right, remember, f of x and g of x are fancy ways of saying the letter y. Y equals are depicting it's a function. It's just, since there's more than one different function I'm talking about, the f and the g are just naming them. You really can put any letter there. It's just giving a name so we can distinguish between the two. Like I could say that this first one's f of x and this is g of x. Just so when I give you something like this, you know which to replace where. All right, multiply, don't forget to use your FOIL method. So 2a times 3a is 6a squared. 2a times negative 4 is negative 8a plus 15. So negative 8 plus 15 is a positive 7. And then 5 times negative 4 is a negative 20. Nothing else can be combined. All right, same thing over here. We have a little more terms than just foiling, but same thing, you're just distributing. So I'm distributing the 5x to everything over here, which gives me 20x cubed plus 15x squared minus 5x. All right, now I'm going to go ahead and I'm going to distribute the negative 2. Please be careful of your signs. Which gives me a negative 8x squared minus 6x plus 2. Okay, right? Once again, signs, signs, signs. And then combine your like terms. So we get 20x to the third. 15x squared minus 8x squared is a negative, oh, sorry, positive 7. JK. Negative 5x minus 6x is negative 11. And then you got the plus 2. Okay, nothing else can be combined together. All right, so operations. Now let's talk about compositions. Okay, this is something new. All right, so composition we take a look at and looks either one of these two ways. A composition of a function is when you're taking one function and you're substituting it in place of the variable of the other function. Okay, you could be substituting in numbers and simplifying completely in numbers. You could be substituting in entire functions. Okay, we're really going to use this on our next lesson when we are talking about inverses and how to determine if things are inverses of each other, if functions are inverses. So this is not fog, okay? This is read as f of g of x. And whether it's displayed this way or this way, they're the same thing, okay? But notice, no matter what, the g is on the inside. So whenever you're working with compositions, you're always going to work inside out. So what we do is we take whether if it's a number, okay, so let's say this said f of g of 3. I would take 3 and I would plug it into the g function. Okay, and we'd have to have a rule. So like down here, you'll see, oh, there's a rule. So I plug the 3 into that variable and I simplify it. Then I take that answer and I plug it into the f function and I simplify it, and that's my final answer. Okay, I could have 10 more things listed out here and we would just keep going inside out. You can also take entire functions, so when it's written in terms of x, this one's saying plug x into the g function. Okay, well I see it down here, there's already an x there. So then I'm taking that entire function and plugging it into the variable of the f. Okay, so let's go ahead and actually do some examples so you can see what I'm talking about. So this one says f of 2. So this is just, when we're doing it reevaluating, all we're doing is plugging 2 into the x value for my f function, which is right here. So I'm just doing 3 times 2 plus 2. This one's not a composition because I don't have more than one function. Okay, we're just practicing plugging something in. So then we do math. 3 times 2 is 6, plus 2 is 8. That's cool looking 8. So we've got f of 2 equals 8 when I plugged it in. And now what this is a point on this function, guys. If we were to graph this line, the point 28 x comma y would be on the line. Okay? All right, so now we have variables. Need a thinner marker. Okay, so it's saying plug x into g. Well, it's already written in terms of x, meaning with the variable x. All right, so if I wrote g of x equals 4x squared. Okay, I don't need to do anything there. So now I'm plugging this, the 4x squared, into the f function. So I'm doing f of 4x squared, because that's what I'm plugging into the f function. So I'm going to take this one, and here's my f function. It's 3 times x. So what I do is I first put a big old parentheses where the variable was. So this is the f function, 3 times x plus 2. Now I'm taking this and I'm putting it in place of where that variable was. All right, so first when I go through, I write out the outside function, and then I, where there was a variable, and if there's more than one, I put a parentheses in its place, so then I know, okay, now I'm going to go back and substitute it in, and then do math. So 3 times 4x squared is 12x squared plus 2. So I'm not simply multiplying the functions. That's not what that's saying. I'm going ahead and I'm substituting it in place of, because if I were to multiply, I'd have to distribute the 4x squared to both, and I don't. So please be careful. The composition is not multiplication. All right, now this one is written the same way. I mean, it's the same problem. It's just written with the f of g. But when we do it, we will get the same answer, because you start by plugging it into the inside and then the outside. But to save us from practicing the same thing again, let's go ahead and let's flip this around. I'm going to have you do g of f of x, because I want to show you that order matters. Come down, f. Woohoo. Okay, so this time we're plugging it into f of x first. So f of x equals the 3x plus 2. Now I'm plugging that into my g of x. So I'm doing g of 3x plus 2. Okay, and I'm doing 4, and then I have my x, so I put parentheses, squared. So this goes here. So I'm going to have to FOIL. So sometimes it'll be a little bit more work than others. It all just depends on what your operations are, I'm sorry, your functions, and then which order that you're doing them in. So I'm going to go ahead and FOIL that out. So I've got 4 times, sorry, I'm sick. 3x times 3x is 9x squared. That's a 9 I swear. 3x times 2 is 6x, and I'll end up doubling it from when I FOIL, which gives me 12x, and then plus 4. And now I'm going to go ahead and distribute my 4 through. Remember, we're simplifying, we're not factoring here. If you were then to try to factor it out, you would end up right back where you are here, so it's not what we want to do. We're multiplying through. Plus 48x plus 16. So that's my answer. All right, let's try this with a new function. Let's go ahead and do h of f of x. And you can rewrite it if it helps you to see it better, like this. Okay, just remember it's the same thing. So first, my f of x is a 3x plus 2. Now I'm going to plug that into h. So I'm plugging in 3x plus 2 into h. And h is just x minus 6. Okay, so nothing too crazy. So I've got x minus 6. Now I'm plugging this in down here. So when all said and done and I do the math, you just end up with 3x minus 4. And that's my answer. Nothing too crazy. All right, there's 6 more problems on the back. I want you to pause the video and try them on your own. But before you do, How many of these are compositions? Just take a minute and look. Yes, only 3 of them are. I'm going to pretend that you said 3. Yes, correct. 3 of them are. It's number 3, 6, and 5. 4 is not. That's a common misconception. That's a multiplication symbol. Okay, you can tell the difference because multiplication is kind of closed in. If you think if you're closed in open circles, it's closed versus a composition is an open symbol, kind of like a degree symbol. So please just be careful. This is just multiplying your two functions. You're just doing 2x plus 4 times that. Okay? All right, go ahead, pause the video, do the examples on your own, press play again to check. Pause. Now. All right, take a look. The first one was just adding. Second one, subtracting. Distribute that negative. Number 3, substituting 2 into G, taking that answer, which was 8, putting that into F. I got 20. Number 4, I'm just foiling it out. Number 5, taking G and plugging it into F. And then 6, doing that in reverse. All right, so if you want to pause the video to go ahead and take a look more closely at my work, feel free. I'm going to go ahead and stop it for now. Make sure you do the practice.